Hey guys, okay, after the last fly through, there were some comments made, and Barbados also informed me that there were some concerns as to possible, let's say, performance issues as to hardware requirements to play Urban Terror HD using the Unreal 4 engine. So I thought I'd do a bit of a follow-up, a walkthrough to kind of, you know, give people an idea where we're at so far as to that obvious requirement. Obviously, we want to make sure that the performance envelope is, well, within reason to ensure that our players have let's say, a pleasant gaming experience. Of course, to sort of put it out there right from the start as to what would be considered the minimum hardware requirements to run Urban Terror HD. To be totally honest and no BS, we don't know at this moment. It's more of an impression. You can't prove an impression, and certainly though that we are not running on just pure assumption alone. So we are taking steps to ensure that the outer limits is a little bit more important at this time, as far as extreme, let's say, settings and graphic visualizations and what have you are put into place from the start, and then use that to be able to calculate a backwards path to, let's say, a lot more reasonable settings. So to kind of start out with, I'm going to feed a lot of the ideas of how we've been over the years, not sitting around and just thinking about, well, when it actually happens, we'll kind of roll the dice. But instead, we were taking some of the ideas that were put into, let's say, the conceptual environment as to what is actually a performance hindrance versus something that has a very low impact as far as performance goes. So for sure, we're paying close attention to that. And as somebody suggested, we will certainly be going into some form of at least some form of hardware alpha testing, to so we're not making assumptions. So we're obviously we can create a performance, a really good performance envelope on a standalone environment, local, being as what you see in front of you right now is local to me. So I have control over the various performance aspects at that level. Things change, as we all know, once you start putting environments and people into a network-based game. Certainly, as far as network codes, which is part of the equation. What gets priority as far as information is being sent. So, what is actually a hit at that stage is something that you really didn't consider beforehand as being a valid point. So as an example, let's take physics for, real world runtime physics, things that happen while the player is playing, and a formula kicks in, and it just happens, things happen based on real life conditions. That's certainly a significant performance hit because, well, first of all, you have the replication problem. What happens on the server obviously has to happen on the client, but because of replication, meaning that an event that occurs on one end has to be the same kind of event that occurs on the other, and it cannot be maintained using physics. So let's say, for example, we have a booby trap set up with a bunch of logs, and they roll down the hill, and there's two characters on the bottom of the hill, and the percentages of one of them being killed versus one of them staying alive is an unknown variable because of the physics nature. So on the server might decide, okay, player A is the one that gets killed versus character B who survives, but yet character A on the client is in a position where it's obviously they're not going to get hit. but all of a sudden the server decides, oh, you're the one that's dead, so the guy that should be dead is not, and the guy that's alive should be dead, kind of thing. So to be able to create a connection between that, obviously would need a far more, let's say, calculations, CPU bound type of valuation, type of what is actually occurring currently between the client and of course the server. So those kind of things obviously will be avoided. Scripted physics, I don't see that being a problem, but certainly anything where there has to be an evaluation where the dependencies on the client versus the information that the server puts out there is a significant performance problem. Well, let's just say that in general, as using physics as just one example. So this is the type of things that can become involved. So certainly, the long way around is saying that to know, we are certainly going to have some form of hardware alpha testing, similar in the same way we did with the FS Tech 1, which worked out pretty damn good. So anyways, moving on a bit, what I'm going to do is I'm going to do the same. I'm going to do the same fly through as demonstrated. Actually, let's set up the specifications here. Okay, as to the big numbers. I'll be running at 1920 by 1200, which is a little bit larger than the 1920 by 1080, which is HD. That's when you start getting into HD territory. And my settings for my project is set to maximum. So as you can see, everything as far as distance, anti-aliasing, post-processing, shadows, textures, and effects are all set to maximum as high as you can get. Material quality high, so that means that let's say very reasonable materials, yet with qualities like normal maps and specularity and that kind of thing. Certainly there's going to play some form of impact as far as performance goes. Shader model 5, to be honest, I'm not too sure what that means. It has to do with DirectX 11, OpenGL, access to different driver models, of course, means different types of effects, as well as we can do some load testing, as you can see, more mobile or on HTML. That's available too as well. Some of the features that are available as far as load testing goes, you can create a proxy of what you expect this whole shebang would run on. So a good one would be to sort of configure things as a desktop, and then compare that to how the game would run on, say, a portable unit. So that's available as the ability to test that kind of thing. What else do we have here of noteworthy? I guess that's about it. Needless to say, everything is set to a max. I mean, there's no bigger number. Now, as to performance, as to hardware configuration, let me kind of bring that up to onto the side here. Okay, CPU. Okay, I'm running Windows 7 Ultimate. Service Pack 1, doesn't mean much. Intel Core i7 2600 CPU with 3.4 gigahertz, 32 gigs of RAM, and a NVIDIA GeForce GTX 780 Ti. No sense in the imagination, is just a slug of a computer. Of the CPU memory requirements that I mentioned here, the amount of memory I have is not a requirement. It's simply a comfort zone, as most times I'm running with 5 or 6 different applications open at the same time. So I'll have 3ds Max on one end, and then I'll have Motion Builder running, and then Photoshop, and then of course I have chat clients open, half a dozen Microsoft Windows, and and then I'll have Audacity sound editor going to all those, and honestly, to shut everything down is the quickest way to do that was just to kind of unplug the computer, so to speak, to kind of shut things down for the day. But most times I just leave it on because it's such a pain in the ass to kind of set everything back up to how I had it previously. So a lot of backloading going on as far as a lot of different applications running at the same time. So at the moment, kind of set up like that right now. Certainly have 3ds Max up and running in the background. I have video compressor running, and how many windows I'm running? Looks like about maybe 6 windows going on, and so with that kind of let's say preamble of what you're going to see, what I'm going to do is I'm going to run this at full screen, and I'm going to run it run Matinee with the frame counter on, and then we can take a look and see exactly the numbers that we're getting as far as this current configuration goes. Okay, let's see. Should I make sure that let's make sure that that FPS is turned on, so when we hit play, yeah, okay, and then we'll go big big screen. Now the number you're seeing on the far right corner there is the current frame rate, and is in fact a totally unreliable number. Now the reason I'm mentioning that is because with each iteration, each preview that Epic is coming out with, something is fixed and something else gets broken. So in this case, that number is unreliable as a means of being able to judge the overall performance envelope. It changes. I've seen this go as high as 110. I think I think the engine is probably capped out at 110, but I really haven't had any need to find that out for sure. But sometimes it changes even with each individual pass through. So as far as stability, as to being able to produce reliable numbers, as to what's actually happening with performance, that's impossible, really. You can only base it really on the overall performance of how it feels. Is it performing within an expectation without focusing on the number? So most times I don't even turn it on. I leave it off, and I let my impression of how, because I'm certainly familiar with this environment. So as I start progressing and making things more into it, the numbers become no more. Well, in combination with a whole bunch of different things, the numbers become. You're no longer assuming what will happen, rather than getting a feeling that everything's on track and within expectations. As I mentioned before, as part of the preamble, the setup that this is max setting as to what is currently available in Unreal 4. Also to mention, there's some as part of the post-processing. That's an interesting little gizmo widget that we can get into later on. I have depth of field turned on. I have eye adaptation turned on, which is another load consideration, and as well as a few other let's say enhancements that creates a pleasant looking environment. So mentioning back, just because an environment looks good doesn't automatically mean that you have performance problems. Sit a little bit more forward so you can hear me a little bit better. Okay, now let's go through a bit of a walkthrough and talk about what's going on here, how this map is set up, and what it's intended and designed to do. And as I mentioned at the beginning, the best course at this point in time is to load things up, make it as heavy as possible, so when we get 10 players running around it, we can get the highest failure, let's say, as far as performance goes, as to expectation. So if we say, okay, well, you know, go down as low as a GeForce 3, then it's not, performance is not really going to be a concern. So this is where things are starting to get a little bit interesting as we kind of do a walk around. So I'll just kind of fly a little bit around here, kind of look up, you know, leave it at full screen, and the numbers kind of jumping around. As I mentioned, it's an untrustworthy number, so don't place too much into it. But as we kind of look around here, this particular model is of interest because its full resolution is about 200K in polygons. So that's about 400K tris, which is would be considered an unreasonable amount, an insane amount of polygons as a single, let's say, map object. Now, you would never do this. We're going to get to some interesting points on, as to that. So as we kind of look around, okay, I'll do a little bit more of a spin around here. The frame rate increases in all probability because there's less background information to render out than there is if we turn this way, and the frame rate goes down as the other various elements become into view. So we turn around, and the frame rate goes up. I mean, it's crazy talk. That's a lot. That's a lot of K there. That's the same for this model over here. This is a hero model. They do have LODs. I just put them in there just to kind of get an idea of the performance differences as to putting in lower detailed models based on distances. But once again, as we turn, you know, the trees are obviously a bit of a chunk. As we turn back, the frame rate goes up. So we just proven there as fact that the amount of polygons that is contained on a given model is rather moot as far as performance goes. So let's move on to maybe something a little bit more interesting as far as observation goes. Well, I'll put them in. I'll talk about them, and I'll just put it in the links into the comment section there, so you can kind of follow up onto it, and you know, and not have to take my word for it. But of interest, the problem of pushing polygons is a problem that has been solved years ago, and in my humble opinion, I would say that started to occur with the introduction of the GeForce 3 video card. As I remember, I can still remember seeing the promos for it and how much I really wanted it. And unfortunately, it was well, somewhat false advertising, because there was really no programs that would take advantage of the different types of software or anything like that would take advantage of the power and flexibility of the GeForce 3 card. So it never really, let's say, reached its ultimate limits as far as possibility goes. And that's the same thing with any other card that you buy today. You know, video games are like 5 years behind the tech that has been applied to a card, and being able to take advantage of that. So this is where things are a little bit different with Epic as far as the engine goes, because well, they're in the business now, of course, of subscription-based engine licensing, and they're constantly updating, which is, as I mentioned, a bit frustrating. So, you know, this map is a really good example. I know it's kind of getting a little bit boring and having to see it over and over again, but through each iteration, each update, there is always something a little bit different as to overall performances, changes, and what have you. So, typically, I got to a point, probably starting out in 4.6, in the later preview versions, of getting a little bit frustrated of getting the lighting to work the way I wanted it to. So, you know, and each time, each iteration, I basically stopped messing around with it. I got well, I wouldn't say upset. I just got said, heck with it. I'll just go off and work on something else. So with each version, the engine improved as far as looks goes. The lighting solution got better, ambient occlusion got better, and of course the shadowing started to blend in, and of course the light back scattering started to start to bleed into areas that were problematic, like this area down here. It was kind of like walking from a hot shower into a cold swimming pool. So you had this very aggressive change in shadowing, which was definitely not unnatural. Now, is that a performance issue problem? No, not at all, because that's a static light mapping effect. And to kind of mention that this is something that we've kind of in theory proved previously already in when we were working on the FS Tech 1 engine, as to the idea of controlled baking. You know, you take your map, you put it into 3ds Max. In 3ds Max, you put all your ambient occlusion and your lighting effects, and you bake everything into the texture. So this created, of course, you know, something that would do like with 10 megs worth of texturing information, kind of bloomed up to like 100 megs worth. So, but as far as packaging size, it's not a bad hit as long as you use it on small maps. So part of the link I put in the HD Grandhall fly-through that we used this technique as far as we could go with with that technology. So Unreal 4 uses the same kind of technique for lighting maps that are static, that are baked into the texture, so it's a zero impact problem. So you can make and it's really good. It's really a really good light mapper. Oh, excuse me. God, something went down the wrong way. So so by comparison, what is kind of hand in hand with that is materials. Now, materials is where things get kind of hanky, even in the Tech 3 FS Tech 1 design, where a shader has can introduce drastic impact. So looking at the Grandhall example, I put it out to Q&A with the baked-in light mapping information and this and that and the other thing. If you look at the wireframes, I mean, there were a substantial amount of geometry based that was put into that map for the very reason of testing engine loads based on CPU scaling. I know this is probably a little bit dry for most people, but which is the reason why I don't really talk about it, because it's a bit boring. But it is pertinent as to performance. So light mapping and materials. In this case, each of the materials has a sub, let's say a sub lighting model based on the type of material that you want. So if you're doing metal, there's a shader for that, and if you want to add in normal maps, there's a position for that. But probably a little bit more important than that is the overall lighting solution that would affect a given object as a painting by light type of with lights type of approach. So if we look at the bush here, there's a lighting model for foliage, and that is one of those things that has gotten better over time. So as well as being indicated as part of that performance swing. Okay, so now, realistically, we have light maps, which is a zero performance loss, which is for I would say a good 90% of how an environment looks like is what plays the role. So even though this was a good-looking map, it's just, you know, it just looks good because the light mapping works. It's almost a zero impact as far as geometry goes, which we have proven. You know, we show a 200K model. Now let's compare that. Okay, so you know, I already have a file set up here in 3ds Max, and this is Casa. This is Casa pulled 100% out as part of the .map file, then brought into 3ds Max, and then of course the material pathways and everything else has been corrected, and we've taken this and we dump it into directly into Unreal 4. Actually, this was the first map that we did as part of our test in UDK. But if we look at the poly count, the number of polygons is 12K. number of triangles for the total map environment is close to 24K. So if we compare that to the single model in there, the hero model, Neptune, that one model is comparable to, let's say, let's just make it easy and say it's 10 times the amount of geometry that's in an entire map like this. So as you can see, it's certainly unreasonable, but as a form of being able to load test in real time as to assumptions and compare that against facts, it's it's a non-issue. So it really is. And we even note that as part of the development of the FS Tech 1 engine using Grandhall. If you look at the video that I'm going to post on the end, it's actually a pretty bad video, and it's hard to tell anything out of it, but the geometry at the end of it, we showed a wireframe. That wireframe is, well, the total map within visible range is about 350K, which once again, you know, you compare that to against the CASA, which is 12K polygon, double that for TRIS. It's a non-factor, even in an engine as old as IDTech 3. Or, in our case, I believe those improvements were significant in FS Tech 1. So, okay, moving on. The last little bit of information is, okay, well, I did a 750K player model test using Motion Builder, and I'm going to post a link to that, so that'll give you an idea of how fast that is able to push out data. But to kind of illustrate it a little bit more as to performance of your average, say your average GPU. So that's what we're really looking a lot more focused on, is GPU processing. I'm going to post a link to Mythbusters' example of a comparison between CPU-bound processing versus GPU parallel processing, how quickly this stuff is just kind of just spit out. And if you watch the video, Urban Terror on IDTech 3 is Leonardo. Unreal 4 is Leonardo for 2.0. So that'll give you a better idea of well, let's see, a sense of the kind of performance envelope we are expecting. But as I mentioned previous to this, you don't really know until we can get that hardware alpha testing up and running, and we can start comparing one number against another. And we are going to intentionally build in some let's say control points of extreme ludicrous types of areas as a form of control. So in this case, you know, yeah, 200K is insane, but for the purpose of saying, okay, if somebody's looking at this direction and they're getting the same results that I am as far as frame rates goes, in actuality the frame rate goes up and not down, then that's a pretty valuable number to be able to kind of you know, keep things within reason and within line. Certainly on when somebody starts to set their overall quality levels lower than what's really necessary or actually required. So I hope that's a little bit you know, makes people feel a little bit more confident that we are at least certainly aware of the need to maintain low specifications. But on a personal note, as an opinion, I think it's rather unfair that somebody goes out and spends a chunk of change on a cutting-edge, state-of-the-art video card, and they just don't buy one. They buy like 6, and they stack them in there. And even at that, even with that amount of horsepower behind their video card, it doesn't really do anything as far as increasing the performance of a engine that is based on 15-year-old technology. That these types of performance enhancers, you know, steroids weren't even available at the time. They weren't even conceived of. So, as much as we want to make sure that people that with lower-end computers can play, we want to make sure that those who are actually want to go out and, they don't want to go up on the hill with a 2x4 thinking and trying to convince everybody it's a snowboard. They want to go out and buy some serious hardware, and we want serious players by becoming a lot more involved, obviously, in the HD brand, which is, rather conceptual at this time. So I hope that's that should be more than enough for now. As we move forward, we actually get into the alpha testing. The one thing we really didn't do with the HD alpha testing was to kind of consolidate the results and let people know what was what and what we discovered through it. So I'm going to try to make sure that at some point we make sure that that type of information gets out there, so the tweakers can do their thing and they have at least a good understanding of how things are going to work in the future.